And glad to be back. So I'll be hooding three students here, and the first is Mr. David Abram. David did his undergraduate chemical engineering education at the University of Illinois at Urbana-Champaign, and he's very interested in working on materials for energy applications. And there are really two very infamous materials out there in our ecosystem that we're not very fond of, and he worked a lot to get rid of them. And one of those is mercury. Nobody really likes mercury in their system, and carbon dioxide, which is pretty much public enemy number one these days. So what did David do? So what David was interested in is, first of all, mercury. The way that mercury enters the ecosystem actually has a lot to do with coal-fired power plants, and coal-fired power plants have a lot of issues, one of which is that because mercury is found in coal, when you burn the coal, the mercury enters the atmosphere and such the cycle begins. He was working on doing some very fundamental studies on how materials can absorb and adsorb that mercury and prevent it from entering the atmosphere in the first place. So really wonderful work there so that we can ultimately design better materials for that application, very important health issue. Second thing regarding carbon dioxide is we're all breathing carbon dioxide right now at 400 parts per million and rising. And the question that David was exploring is, can we take that carbon dioxide and recycle it? Can we use renewable energy to convert that carbon dioxide back into something useful, back into gasoline, or into a plastic that becomes a milk jug, for instance, and then you can recycle that and it's basically a solid form for the rest of its life. So he was interested in engineering materials that can catalyze those chemical transformations. And more specifically, he was interested in metals, and then using his knowledge on just straight metals to make metal alloys that were better for that application. And then very interestingly, combining metals with polymer materials, with plastics, and that combination could show some really interesting improvement in that catalytic transformation. So that's the subject of his PhD thesis, and I also just want to thank him very much for being one of the first handful of students to join my lab and really to be part of that initial team that got our lab. When he joined, our lab wasn't much, and it became something really interesting and exciting place to work for all his peers that were coming through the ranks after him. So for that, I thank him very much. Congratulations, David.